In column 1, some physical quantities are given and we need to match them with various characteristics given in column 2. Let's start with the first one. Here delta E is given as 0 and delta H is also given as 0. Here we have the relation enthalpy is equal to the sum of internal energy in the pressure volume type of work. So we cannot even calculate the exact value of enthalpy also. So we'll always calculate the change in enthalpy, which is delta H equal to delta E plus delta PV. Now for isothermal process, we know that the change in internal energy is equal to 0. The internal energy of a system remains constant whenever the temperature is maintained constant. Then we also know that PV is equal to constant at constant temperature, that is in isothermal process. When PV is equal to constant, so delta PV is definitely equal to 0. Delta E is 0 and delta PV is also 0. Definitely delta H is also equal to 0. So that is the reason for this A, the correct matching is S. That is for an ideal gas undergoing expansion isothermally. The next one, here delta H is given as negative. We know that the non-ideal solutions, they do not obey Raoult's law and the enthalpy of mixing is not equal to 0. And again delta V mixing is also not equal to 0. Specifically when we discuss about the reason for the negative deviation of a non-ideal solution, it is like this. This is observed whenever the solvent-solute interactions are stronger than the solvent-solvent interactions and solute-solute interactions. So when compared to the pure substances, in the solution, the attraction forces between solvent and solute are more. So as the attraction forces are more here, definitely heat will be released when we are making a solution of these two substances. So that is the reason why here the enthalpy change is negative for the non-ideal solutions with negative deviation. So definitely this should be one of our correct matching. And when you see this example, hydrogenation of alkenes. Hydrogenation is an example of exothermic reaction. So that is the reason even for this one the delta H is negative. So for this one we have two correct matching. One is Q and other one is R. Then the third one is delta S of universe is equal to 0. We know that for a reversible process, Q of system is equal to minus Q of surrounding, isn't it? When heat is given by the surrounding to the system is absorbing the heat, so it is represented as positive value, and surrounding is giving out the heat, so it is represented as negative value. And since we have delta S of the universe is nothing but equal to delta S of system plus delta S of surrounding, and this is equal to, and delta S system is equal to delta Q system upon T, and delta Q becomes equal to minus of delta Q surrounding. So this is minus delta Q surrounding upon T, and delta S of surrounding is nothing but equal to delta Q surrounding upon T. Delta Q surrounding upon T, and this value becomes equal to 0, isn't it? So that is the reason why for C the correct matching is only P. The last one, the delta G mixing is negative. We have the relation delta G as equal to delta H minus T delta S. Already we had just discussed that delta H mixing is negative for the case of non-ideal solutions with negative deviation, isn't it? Then delta S mixing is positive because whenever we are making the solution, the degree of randomness increases. So that is the reason why the entropy of mixing is positive. When this is negative and this is positive, definitely our final answer will be negative, isn't it? So here delta G is negative. So that is the reason why for D the correct matching is only Q. So overall matching is like this. For A it is S, for B it is Q and R, for C it is P, for D it is Q.